Hi guys, so today we're going to be working on the Ready to Go On. I am on page 423. This is for chapter 13. Number 1, find the probability of each event. Write your answer as a fraction, as a decimal, and as a percent. So, you choose a marble at random from a bag containing 12 red, 12 blue, 15 green, 9 yellow, and 12 black. The marble is red. So, what was the probability of that event? Well, first of all, there were 12 reds out of a total of, just a sec, I don't seem to have my calculator. So I have the 12 reds, so what I need to do now is figure out how many balls were in there to begin with. So I do the 12 plus 12 plus 15 plus 9 plus 12 gives me 60. So 12 out of 60. Well, I can take stuff out of that. I can take out a 2. 12 divided by 2 is 6. 60 divided by 2 is, 2 goes into 6 3 times, 30. Okay, I can take out another 2 because they're both even. 6 divided by 2 is 3. 30 divided by 2 is 15. I now have 3 over 15. I can take out a 3. 3 divided by 3 is 1. 15 divided by 3 is 5. So 1/5. That is my fraction. Now the way that I turn that into a decimal is I go 1 divided by 5, literally. And it tells me 0.2. That is my decimal. The way I change that into a percent is I move the decimal point 1, 2 times, and it becomes 20%. So I have 1/5, 2/10, and 20%. Number 2. You draw a card at random from a shuffled deck of 52 cards. The deck has 4 13 card suits. The card is a diamond or a spade. Okay, so 13 hearts, 13 diamonds, 13 clubs, 13 spades. Okay, heart or, no, sorry, diamond or spade. So that's 2 options. 13 plus 13 is 26 out of 52. Okay, I can take out a 2. 26 divided by 2. 2 goes into 2 once, into 6 3 times. 2 goes into 5 twice, into 12 6 times. I can take out a 13. I know that's not obvious to you, but I know I can take out a 13. Because 13 divided by 13 is 1, and 26 divided by 13 is 2. So I am left with 1/2. I plug it into my calculator, 1 divided by 2. That will give me a 0.5. Or 5/10. I need to make that a percent. I move the decimal point 2 times, giving me a 50%. Number 3. A bag contains 23 red marbles, 25 green marbles, and 18 blue marbles. You choose a marble at random from the bag. What color will you most likely choose? Well, which do we have the most of? Green. You will always be most likely to choose the one that you have the most of. Okay? Always. That's just kind of how it works. Number 4. Bay City has a 25% chance of having a flood any given decade. This table shows the results of a simulation using random numbers to find the experimental probability there will be a flood in Bay City in at least one of the next 5 decades. In the table, the number 1 represents a decade with a flood. The numbers 2 through 5 represent a decade without a flood. According to this simulation, what is the experimental probability of a flood in Bay City in at least one of the next 5 decades? Okay, so what we are doing is we are looking for a row that has the number 1 in it, because only the number 1 means that it was flooded. So first trial, nope. Second trial, nope. Third trial, nope. Fourth trial, yep. Fifth trial, nope. Sixth trial, nope. Seventh trial, yep. Eighth trial, yep. Ninth trial, nope. 10th trial, yep. So that is 4 times out of 10. 4/10, 4 times out of 10. We did it 10 times. 4 of the times we had a 1. So 4 times out of 10. We're going to divide that down. Divide by our 2. 4 divided by 2 is 2. 10 divided by 2 is 5. So it ends up being 2/5 of the time it will flood. It'll only flood 2/5 of the time. Number 5, how can you use theoretical probability to make predictions in real-world situations? If I know how likely something is, I know if I should be expecting it or not. This is a little like sitting here talking about when are we going to have rain in California? You know, right around here, when are we going to have rain? We can say, well, most years we have rain in January, which is true. Most years we have rain in January. Have we had Januaries where we really didn't have all that much rain? Yeah, but most years we have quite a bit of rain in January. And so we can sit there and I can say, it's January. We're probably going to have some rain. I'm probably going to be looking up at the sky and watching clouds gather. That's how we use probability in real life when we're actually doing things. It's, well, around this time of year, it's probably good weather for planting. Is it always good weather for planting around this time of year? I'm sure there was a time or two when it wasn't, but most of the time it is. And so that's how we decide when we're actually going to plant things. Probability in real life. Now we're going to, on page 424, the assessment readiness. Number 1. Is it possible for this cylinder to have these shapes? A, could it be an oval? No. A cylinder has a circle at the top, circle at the bottom, and a rectangle wrapped around the entire middle of it. B, A rectangle. Yes. As I just said, if we cut it down the middle, you have a rectangle. C, a triangle. No. I can't think of any way we'd have a triangle. In fact, the only one that you could possibly argue about is whether or not you could have an oval as part of a cross section, because if you cut it at the right angle, you might be able to get something that kind of looks like an oval. It's not really an oval, it's a circle. Number 2, a bag contains 12 red marbles, 6 blue marbles, and 2 green marbles. Okay, so number 2, 12 red, 6 blue, and 2 green. Okay, so this is small numbers. This should be easier to deal with. Probability of randomly selecting a blue marble is 1/6. Okay, so there's 6 blues out of a total of 12 plus 6 is 18, plus 2 is 20. We can divide out a 2. 6 divided by 2 is 3. 20 divided by 2 is 10. 3/10 is 3/10, 1/6. Nope. So A is false. B, the probability of randomly selecting a red marble or a green marble from the bag is 70%. So I have to do red plus green. Red is 12. Green is 2. 12 plus 2 is 14 out of 20. Once again, dividing out the 2. 14 divided by 2, 7. 20 divided by 2, 10. 0.7, 7/10. So we rewrite it as 7/10, and then we move the decimal point to make it 70%. Is that what B says? That is what B says. So that's true. And C, if you choose and replace a marble 30 times, you can expect 3 of the marbles to be green. Okay. Well, let's look. That's a kind of weird question. All right. So this is how we're going to determine this. If I go 2 are green out of 20, and I'm going to go 30 times, and I want to know how many are going to be green. Okay, so I'm going to set this up. I'm going to do cross multiplication with it. So I end up with 2 times 30 is equal to 20x. Okay, with me so far? 2 times 30, 2 times 3 is 6, 0 equals 20x. I'm going to divide both sides by 20. That cancels out. 60 divided by 20, I can get rid of the zeros at the end. So I'm left with 6 divided by 2, which is 3. X is 3. Well, if you recall, X was the green, and so C is true. It would be. Do you know why I did it this way? Because this is how many chances it actually has. It actually has 20 chances. This is how many chances we took. Okay? Actually has 20 chances. We took 30 chances. So I needed to change what happened at the top. Actually has 2 chances, but because of how many we took, it now has 3 chances. All right? That's what we're doing. We set up how much it actually is, and then we figured out, yeah, okay, fine. I know it's 2 out of every 20. But if I switch it around a little bit, and I, instead of pulling out 20, I pull out 30, how many is it going to be? It would be 3 for every 30. Okay, number 3. This table shows the taco options at a restaurant. Each month, the manager randomly chooses a meat, a tortilla, and a salsa for the taco special. What is the probability the taco special in June will be chicken on a corn tortilla with mango salsa? Okay, so I have beef, chicken, and pork. Let's make our graph. Beef could be on either corn or flour. Chicken could be on either corn or flour. Pork could be on either corn or flour. Yes, I am not writing out the entire word. Salsa is there are 3 kinds of salsa. That's why I'm writing in all my 3s. Okay, so chipotle, mango, and verde. Chipotle, mango, verde. Chipotle, mango, verde. Chipotle, mango, verde. Chipotle, mango, verde, and so on and so forth the whole way down. Okay, so all that's really necessary to know is these endpoints. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's all that I need to know. I have 18 possibilities. How many of those possibilities will lead to it being exactly chicken on a corn tortilla with mango salsa? 1. One of those possibilities leads to that. It's only the 1. So it's the 1 out of the 18. Yeah, 1 out of 18, because that's all the possibilities that we have. Okay. Number 4. A weather forecast states there is a 20% probability of rain on each of the next 3 days. Describe a simulation you could perform using random numbers to find the experimental probability that it will not rain on any of the next 3 days. Okay, so since we're dealing with 3 days, we will need 3 numbers. Okay, 3 days, so 3 numbers. 3 numbers each time. Now, it says 20%. Okay, so we need to talk a little bit about what we can do with this 20%. We can do a couple things with it, actually. It is a 20 over 100 to start with. Now, you could sit there and roll the numbers 100 and have numbers 1 through 20 be if it's going to rain. You could do that. Or we could get rid of the 0 at the end because we don't need that. Roll 10. Or, have 10 as being our options, and then have numbers 1 and 2 be the ones which mean that it is going to rain. Or we could take it all the way, we could divide out a 2, go all the way down to 1/5, and only have 5 numbers, and have the number 1 mean it's going to rain. It will not rain. Yeah. So we would be going for 3 numbers each time. But you have a choice. You can either use numbers 1 through 5. I'm going to write this with a pen instead of a marker so that I have enough space for it. Okay, so 3 numbers each time uses numbers 1 through 5, 1 equals rain. Numbers 2 through 10, sorry, 1 through 10, sorry, 1 and 2 equals rain. Numbers 1 through 100, 1 through 20 equals rain. All 3 of those work. All 3 of those will give you the results that you are looking for. All 3 of those are correct and will answer the question. I'll be perfectly honest with you, I would probably use the 1 through 5 simply because that is way fewer numbers for me to be keeping track of. But you don't have to use the 1 through 5. You could use the 1 through 10, and then you have 2 numbers that you're looking for. Or the 1 through 100, and then you have 20 numbers that you're looking for. It doesn't matter. You can use any of them, okay? That's the point that I'm trying to make here. All of these work, and all of these work quite well. Okay, that's the last problem that we have. Good luck on the test. I'll see you later. Bye.